Hello viewers of the annual refresher program in teaching, in short ARPIT. Welcome to the course on agriculture, namely the advances in agricultural engineering. I am Piyush Soni and I will be taking you through the module 1 of advances in agriculture engineering with an introduction to the agricultural mechanization. This course module will be on sustainable agricultural mechanization, where in this particular module we will be talking about agricultural mechanization. We will be covering the definitions of agricultural mechanization, its benefits, challenges to agricultural mechanization, different stages in the agricultural mechanization and the concerns related to environment in agricultural mechanization. There are some references which I would believe would be useful to the viewers. Book is from the Kepner, Benner and Berger, The Principles of Farm Machinery, the 3rd edition. For the web reference, I would like to recommend the Agricultural Mechanization Strategy by Adrenius G. Reich from United Nations Center for Sustainable Agricultural Mechanization, which is available on the UN UPCAIM website. Let us begin with the agenda for this particular module, the agricultural mechanization. We may have heard of this term a million times, but we would be really interested to know what is its significance, what are its benefits and what is the importance of agricultural mechanization. To understand its importance, we might like to consider what would happen to agriculture if there were no agricultural mechanization. How the agriculture would look like without the presence of agricultural machines. In order to understand that, we would see the burden and the drudgery of the farm work. In absence of agricultural mechanization, our farmers would foresee. At the same time, per worker output will be tragically low. So, basically if we were to conclude in short the benefits or importance of agricultural mechanization, we would assume that with the presence of appropriate agricultural machines, the agricultural mechanization would reduce the burden and drudgery. At the same time, it would increase the output per worker. So, the comfort and economics are coming out to be the two major key points which favors the agricultural mechanization, and very specifically these two are the major concerns which agricultural mechanization have to be dealing with. Why we have to increase the agricultural production? The answers are very simple. Of course, the world is facing tremendous problem of feeding the increased population. To give you some numbers, India is having currently 133 crore of human being as per the statistics of 2017, and we are increasing our population at the rate of 1.19% according to the statistics of 2016, where to put some perspective, we are just second to China, which has got 138.64 crores of people, whereas our arable land is limited. We have to provide raw material for developing countries. Now, there are lots of developing countries which are relying heavily on agriculture for their GDP. India is the world's largest producer of milk, pulses and jute, wherever it ranks as the second largest producer of rice, wheat, sugarcane, groundnut, vegetables, fruit and onion. According to 2018 statistics of FAO, the agricultural sector shares roughly about 14.6% to the country's GDP, whereas it constitutes as high as 43% of the total employed people in agriculture in India. To give you another comparative perspective with China, it stands for 7.2% of its share in agriculture sector, whereas it constitutes 27% of its population employed in agriculture according to the World Bank statistics. Other reason why we are pushed to increase our agricultural production is to provide sufficient food of quality in terms of the nutrition. The food production index, considering 2004 to 2006 production values as 100, the World Bank statistics shows that 2016 food production index for India has been 144.4, whereas as compared to China it is 139. What are those constraints we are facing with to increase the agricultural population? Our land is limited. The agricultural land which is of good quality is declining because it is being used for various competitive uses, including housing, industry. Part of the arable quality land is being eroded, and there are also different uses for infrastructure development such as road, canals, electric power lines, etc., where the agricultural land cannot be used for agriculture purposes. Water is limited. Agriculture is considered to be one of the greatest user, as well as, I may say so, it is also the largest waster of groundwater or the fresh water. Shortage of inputs, including seed, fertilizers and chemicals. Well, we may say so that there has been a plenty of production in and out of the country about these agricultural inputs, but these shortages must be considered in view of its economic shortages. The prices of these agricultural inputs have been increasing very significantly over the last few decades. There is a shortage of power. This also must be considered based on the agricultural dependency on fossil fuel based energy sources, which obviously is going to be depleted. Then we have the other threat of climate. How we can increase the agricultural production? We can increase the cropping intensity. Cropping intensity is defined as the ratio of the gross cropped area to the net sown area. Thus, the higher cropping intensity refers to that a higher portion of the net area is being cropped more than once during one agricultural year. This also implies higher productivity per unit of arable land during one agricultural year. The second tool for us to improve the agriculture production is to increase the production yield. We may go for better crop varieties, we may go for more effective use of fertilizers and pesticides, and we can improve the cultural practices. Then we can go for reduced amount of losses, agricultural losses, both post and pre-harvest of the agricultural produce. To give you some perspective, in 2016, harvest and post-harvest losses of India's major agricultural produce was estimated to rupees 92,651 crores or $13 billion, which is surprisingly almost 3 times as high as 2016-17 annual budget for agricultural sector. Out of this, about 16% of fruits and vegetables valued at rupees 40,800 crores were lost between 2012 and 2014. Legg in 1993 once proposed how many people can a farmer feed, where we can clearly see the role of agricultural mechanization. A farmer with simple hand tools could feed up to 3 people. A farmer along with the draft animal could probably feed up to 6 people, wherever the same farmer with the help of a tractor could feed up to 50 people. Here the tractor is used as the symbol for agricultural mechanization, at least in early days. With exponential growth of population, this equation no longer stayed that simple. There comes the effect of sustainable agricultural mechanization. Now, what is the agricultural mechanization and how various people and researchers have defined it. One of the simplest definitions says the agricultural mechanization embraces the use of tools, implements and machines for agricultural land development, crop production, harvesting, preparation for storage and on-farm processing. It includes three major sources of power, that is human, animal and mechanical, where the manufacturing, distribution, repair, maintenance, management and utilization of agricultural tools, implements and machines is covered under this discipline with regard as to how to supply mechanization inputs to the farmers in an efficient and effective manner. To continue with the discussion on mechanization, we may consider the productivity enhancing technologies, and these are governed by three basic principles or purposes of mechanization. First and foremost is to increase in labor productivity, that is introduction of machinery to substitute for labor, which is the labor saving aspect, to release of labor for employment in other sector of the economy, or to facilitate cultivation of larger area with the same labor force. The second principal purpose of agricultural mechanization is to increase in the land productivity. To produce more from the existing land, machinery is a complementary input which is required to achieve higher land productivities. The third principal purpose of mechanization is to decrease in the cost of production. We do not expect the agricultural mechanization to enhance the cost of production, the total cost of production, whereas it is in contrast there must be a decrease in the cost of production. Introduction of a machine may lower the production cost, or it may offset the increased cost of draft animals or labor. So, we may see that there are three principal purposes of agricultural mechanization. Number 1, increase in labor productivity. Number 2, increase in land productivity, and the third and the most important one is to decrease in the cost of production. There may be a number of ways where we can go for agricultural mechanization. In fact, there are different stages of agricultural mechanization, but which stage or which means of agricultural mechanization is suitable to a agricultural farmer will be determined mainly by these three principal purposes of the agricultural mechanization. Failing to meet either of these criteria perhaps might not qualify that agricultural mechanization solution to be an appropriate solution for a given ecosystem of a farmer. There comes the definition of appropriate mechanization. What if a mechanization is inappropriate? Yes, that is possible. If that agricultural mechanization means are not meeting the one of the three principal purposes of agricultural mechanization, it may be considered as inappropriate for a particular ecosystem. The term appropriate mechanization refers to the level of mechanization and how it is used for a specific situation. Appropriateness can only be determined after carefully considering the technical, economical and social characteristics of each of the situation. Unfortunately, we may not be able to generalize the agricultural mechanization's appropriateness concerning the appropriateness of a particular type of mechanization or particular agricultural tool, implement or machine for the rural development, and that is where they say one size does not fit all. We have been evolving on these definitions. We started with the simple mechanization, or in those days it used to be considered as the tractorization, because the tractors were perhaps one of the major adopters of agricultural mechanization. Then came the definitions of intensive agriculture. Then we started talking about the appropriate mechanization, which includes the size of land, which includes the effect of a particular ecosystem, which includes the effect of how the machines would fit to a particular hands. we are talking about the human factors safety, we are talking about the anthropometric dimensions. Then lately we have been talking about the sustainable agriculture mechanization. We may notice that the earlier terms defined with the agricultural mechanization, may it be the agricultural intensification, may it be the appropriate mechanization, did not particularly include the dimension of environment to it. With the inclusion of environmental dimension to the discussions of the appropriate mechanization, we may now being able to define another more peculiar and more recent term called sustainable agricultural mechanization. What are the benefits of mechanization? Although the list is very long, we may summarize this list by talking about some key benefits drawn out of agricultural mechanization. It should increase the productivity per agricultural labor, it should increase the economic returns to the farmer. The mechanization should be to change the character of farm work, making it less arduous and more attractive, or to bring, in other words, more pride to its practitioners. To improve the quality of field operations, providing better soil environment for seed germination and plant growth. It should offer timeliness and precision in the agricultural operations. It should reduce the loss of crops and food products. It should be able to free the human power for the working opportunities in industrial and service sectors in order to increase the proportion of off-farm incomes to a farming family. It should bring improved dignity of farmer. It should carry out agricultural practices in remote areas with unfavorable climatic conditions. The adoption process of mechanization or labor productivity enhancing technology or labor saving technology has been defined beautifully by Edinus Reich, and he proposed that there are 9 stages. The first and foremost stage of agricultural mechanization adoption process is the application of improved hand tool technology. In many parts of the world, hand tools are still the technology used in agriculture, and even in highly mechanized agricultural systems, improved hand tools are still important. The next stage of agricultural mechanization adoption process include the draft animal power application, where the use of draft animals are substituting wherever the muscle power or muscle energy of human beings are used. The third stage of agricultural mechanization adoption process is the substitution of stationary power. Mechanical power is substituted for human and animal power, which are used in stationary operations. Stationary operations are mechanized first because motive power sources are technically more complex and therefore require higher investment. Typically, operations mechanized at this stage are paddy dehusking, grain milling, pumping the water, and the threshing. The fourth stage of agricultural mechanization adoption process is the motive power substitution. At this stage, the substitution of mechanical power for muscle power takes place for field operations. It focuses on power intensive field operations, for example, plowing, and machinery is of relative simple design and easy to operate. Mechanization is still straightforward and crop production practices are usually unchanged. At the stages 3rd and 4th, mechanization takes advantage of lower costs of new power sources as compared with the traditional ones. The next stage of mechanization adoption process is known as the human control substitution, whereas all the processes which involves human intelligence or human sensing, they may be replaced by appropriate means. At this stage, the emphasis is given on substitution of the human control functions. depending on the complexity of the control function and degree of its mechanization, machinery becomes increasingly complicated and costly. A potato lifter is simple in design, but fruit and cotton harvesting machinery are complex and expensive. Automatic depth and draft control, cutter bar height adjustment are few of these examples. The next stage in the agriculture mechanization adoption process is the adaptation of cropping practices. This stage features the adaptation of the cropping system to the machine. For example, removing weeds in broadcast crops cannot be done with machines, but row seeding and seed drills may be introduced to facilitate mechanization of weeding. Other examples include the increase in row distance to accommodate heavier and larger machines to speed up the field operations. The next stage is known as the farming system adaptation, whereas the cropping system The next stage is the farming system adaptation. The farming system and production environment is changed to facilitate further increase in labor productivity and to benefit from economies of scale, which is necessary to make the investment in expensive machinery financially feasible. An example of this is the rapid decline of mixed farming systems in Europe since the late 1960s, when the farmers specialize in either dairy, poultry, hog or crop production. Some crops which are difficult to mechanize may disappear if acceptable substitutes become available, or if these can be produced in countries with lesser labor cost. At this stage, investments in land development, land consolidation and rural infrastructure are often needed to facilitate advanced degrees of mechanization. The next stage in the adaptation process for mechanization is the plant adaptation. This stage features the adaptation of the plant and animal to mechanized system. Mechanization has advanced to a stage where engineering alone can no longer provide further gains in labor productivity. Breeders increasingly take into account the suitability of new varieties for mechanized production. The examples are shortest versus taller varieties. The last but not the ultimate stage of adoption process for mechanization is the automation of agricultural production, whereas the stage is progressing in countries with high labor costs and sophisticated demands on production and quality is there. Examples are automated rationing of concentrated Examples are automated rationing of concentrate feedings for individual dairy cows based on their milk production and sprinkler irrigation systems activated by soil moisture. Having talked about the 9 stages defined by A. Reich of adoption process for mechanization or the labor productivity enhancing, one thing we must realize that the agriculture mechanization has no ultimate goal to achieve at. This may be considered as a guideline how long or how far we have risen on the ladder of agriculture mechanization, but its suitability, its appropriateness and its sustainability depend on the local ecosystem. How do we expect the future mechanization? The process of mechanization is dynamic, which has got no ultimate goal in its sight. Safety, comfort and convenience for the operator will continue to receive lot of attention in future. Operator will be more and more isolated from the functional portions of a machine, where the degree of judgment can lead to difference in the effectiveness as well as efficiencies of that operation. Microprocessors have facilitated the use of monitors and automatic controls on farm tractor, they will continue to get more and more attention in future as well. Automatic control for complex machine will become increasingly important. Larger tractors are introduced where the tillage tools must be designed for higher speeds or to efficiently utilize the available power in other forms other than the drawbar pull, only so that the traction is not a limiting factor anymore. The difficult areas of mechanization where the mechanical harvesting of fruits and vegetables due to the varied characteristics, delicate and perishable nature, pruning of trees and vines due to the necessity of human judgment, they are still considered to be difficult, and perhaps the future agricultural mechanization solution would bring appropriate solutions to these challenges. Scope of developing more efficient machines that will require less energy per hectare to produce the desired effect on soil. Economic adoption of certain types of machines to small farms is a problem that needs perhaps more attention in the future. Machineries well equipped with global positioning systems and control area network will also get more attention in the future. Simplification of the more complex machine, which is in contrast to the present developmental trend, is needed and is a real challenge to agricultural engineers. Then we may talk about the factors for considering during design of farm machinery. The first and foremost attention must be given on the efficiency of operation. That may include the work quality, efficient utilization of power for a given task, efficient utilization of human power for the particular task. That may include minimum lost time that will offer the least fatigue to each operator, and moreover there must be the safety consideration duly given to the machine. Next is the amount of work to be done before the machine wears out is going to be another consideration while we are developing the appropriate agricultural mechanization. The machine must be free from breakdowns. The machine must be having enough resistance to mechanical wear by friction. Machine must be having enough resistance to the chemical wear, and at the same time it should have low repair and maintenance cost. And finally, there must be the safety consideration, which involves having no sharp corners, no parts lubricated near steps, handrails to climb, controls must be easily accessible, and there must be good visibility of the workplaces. So, there we have come to the end of the module 1, and there could be couple of review questions for us to ponder on. For instance, we have discussed about the 3 core principal purposes of agricultural mechanization. We have distinguished among the mechanization with appropriate mechanization with the sustainable agricultural mechanization. Then we talked about 9 stages in the adoption process of agricultural mechanization, and finally, we talked about some of the trends we expect to see in future in relation to the agricultural mechanization as well as the challenges. I thank you. Thank you very much.